All right. Chapter 7, Section 2 for geometry. We're going to talk about similar figures and work through some things. Hopefully a little bit as a review for you that you are going to recall. But let's work ourselves through. All right, so similar figures. As defined, same size, same shape, not necessarily the same size. So what do we do? What's our check? In order for the shape to be intact, all angles must be congruent. That keeps the shape. Now, for the size, every so often, everything's going to be congruent. But for the size, what we're looking for is corresponding sides being proportional. Corresponding sides are going to be proportional. So if you remember about dilations, some things get larger, some things get smaller with your pupils or your eyeball. Kind of the same thing going on here. So we're going to make, when we do the sides, you'll have two things. It's called a scale factor or a similarity ratio. Big thing here is this: make the same comparison. Big to small, small to big, doesn't matter. Key phrase: make the same comparison. Make the same comparison. So let's check. Example. Are these similar? Let's go triangle ABC. Let's go 10, 12, 14. I'll give you a 60-degree angle here. 70-degree angle there. Triangle E, F, and D. We'll go 6, we'll go 5, we'll go 7. 50 degrees, 70 degrees. So first thing we got to do before all else, check your angles. The side, if the angles ain't matching up, there's no sense worrying about the sides. So as we look, that's going to give us 130 degrees, so that's got to be 50 degrees. That's 120, so that's got to be 60 degrees. So the first check, all the angles. are congruent. Done. Now, let's get a similarity going here in terms of sides, in terms of ratios. Okay, so again, you can compare left to right, right to left, big to small, however you want to look at it. So we look at our corresponding sides. So 60 to 70, there's 60 to 70, so those sides match up. I'm going to go left to right. So I got 10 over 5. Again, your call how you want to do it. Let's say we go 70 to 50, so 70 to 50. I see 12 to 6 is my comparison. And then odd man out, we got a 14 here and a 7 here. And we can see that they all reduce to 2 to 1. So they are proportional. So that checks, meaning what? Yes, the triangles are similar. So if we were to make a similarity statement to go with this, kind of like a congruence statement. However you set the first polygon up, the other one goes off of it. So let's say I wanted to say triangle A, B, C, similar, and just line the angles up when you do it, folks. So I went 70, 60, 50. I'm going to go 70, 60, 50. So triangle D, E, F. Now all my corresponding pieces parts are set. Let's look at this example. A, B, that's B, sorry. C and D, one arc. 2, an arc with 2 ticks. An arc with 1 tick, we'll call this 15. 6, 9, and 12. And for this other part of it, let's go here. Remember, all artistic renditions that you get to witness here are works of art in action. Let's go here with an arc, and it's tick there, call this 6, 4, 8, 2 ticks on that bad boy, 2 arcs there, and a 10. Alright, so what do we want to do? Well, as we look, I want you to write a similarity statement. And then write a statement of proportionality. So let's start first off. Alright, so the similarity statement we look, you can see these match up. This one kind of twists over to that. So how do we want to do it? Well, it's a quadrilateral. Might be a trapezoid, might not, I don't know for sure. So I'm just going to pick, remember that's a B. So A, B, C, D, similar. So from A to B, that's a 1 arc to 2 arcs, 1 arc to 2 arcs, 15 to 10. Okay. B to C. So that goes from here to here, 12 to 8. I look at the ratios. I see some things are going. So I went there, there. How would I follow it? So O, N, M, L. So there's the similarity statement going on. Statement of proportionality. make your scale factor, make your similarity ratio. That's what they're asking. So find your corresponding sides. So AB corresponds with, again, look at the angles, 1 to 2. ON, I'm just going to kind of go around the horn here. BC, I look at the markings, so NM, DC is going to match up with ML, and then DA, AD, however you want to do it. That goes from tick to nothing, so LO. So yes, it's a very long proportion. It's called an extended proportion. But as we look, (15 to 10). And again, we talked about we can check cross products if we like. 12 to 8. And then we've got 6 to 4. You can reduce the fractions. You can do cross products to check this way. There's 36, 36. There's 48, there's 48. There's 120, there's 120. So they're all matching up. Final thing that we want to do on this is then put our scale factor. Factor. There you go. Also known as similarity ratio. I'll abbreviate. Scale factor, similarity ratio. How do you want to do it? I compared this one to this one. So what's all this stuff reducing to? 3 to 2. If you switched it and compared this shape to that shape, or it's a 2 to 3 ratio. This depends how you compare it. This was big to small. Going off of my lead, some of you might have compared to the other. That's fine. Small to large or small to big. Similarity ratios, scale factor, similar figures.